Let's talk about the electron. You know, the fundamental particle, this tiny little traveler that basically powers our entire world. But what if I told you it has a secret identity? That this lone wolf we all know was once part of a big, unified family with the quarks? Well, today we are diving into a really wild theory that recasts the electron not as a different kind of particle at all, but as a long-lost member of the quark family.
So here's where we're headed. We're going to start with the particles as we know them, then we'll literally rewind time to see them in this state of perfect unity. Then we'll watch the cosmic drama unfold, the breakup that changed everything. After that, we'll unveil the electron's new identity in this model, hunt for the ghostly clues this lost family left behind, and we'll end on a really juicy, unanswered question.
All right, so let's set the stage with the universe as we currently understand it. You know, the standard model of particle physics gives us a whole cast of characters, but for our story, we really only need to zoom in on two of them, the two that build pretty much all the matter we see, the quarks and the electrons.
And right away, this gets us to the heart of the puzzle. These two particles are the absolute bedrock of reality. They build you, me, this planet, everything. But for being so fundamental, they act in completely different ways. It's kind of weird, right? So why? What makes them so incredibly distinct?
This right here really lays out just how different they are. Quarks, they're like the social butterflies of the particle world. They are never alone. You always find them in groups of 3 inside protons and neutrons. They're all held together by the strong force, which works on something called their color charge. Now don't think of visual color, it's just a type of charge that happens to come in 3 varieties. Electrons, though, they are total loners. They have 0 color charge, so they just completely ignore the strong force. They just do their own thing with their electric charge. Honestly, they really do seem like they're from 2 completely different worlds.
But what if they weren't? Let's play with a really cool idea. What if this separation, this deep difference between quarks and electrons wasn't always there? What if, way back in the early universe, they were all just part of the same family?
So this whole idea is wrapped up in a theoretical model with a kind of technical name, SU4. Don't worry about the name. What it's describing is actually a beautiful, simple idea. It asks us to just forget about separate quarks and electrons for a minute, and instead imagine a time when there was just one fundamental particle. And this one particle had 4 perfectly symmetrical charges, which made it part of this single unified family of 4.
So what were these 4 charges? Well, in this model, you can think of them just like the color charge of quarks. You've got the familiar ones, red, blue, and green, but then there's this 4th member of the family, yellow. And this yellow charge you're about to see, it is the absolute key to this entire story.
So here is the main takeaway. In this gorgeous, symmetrical, unbroken state, the universe was just simpler. There wasn't one box for quarks and another for electrons. There was just this one 4-component particle. Everything was one.
So if everything was so perfect and unified, what happened? How do we get this divided world that we see today? Well, the answer is a dramatic cosmic event that we call symmetry breaking.
Think of it like this. In step 1, you have the unified family, our SU4 state, sitting around a perfectly symmetrical round table. Everybody's equal. But then, in step 2, something happens. The universe kind of picks a direction. It's like one family member suddenly pushes their chair back and stands up. As you see in steps 3 and 4, that one simple act shatters the perfect symmetry of the group. You're left with a tight-knit clique of 3 that can still interact perfectly, that's what physicists call SU3, and one isolated member who's now totally on their own, the U1 member.
And the consequence of this great breakup, well, it's the universe we live in. It created the 2 distinct particle families we see today. You have the 3 that can still mix it up with each other using the strong force, those are our quarks. And then you have the 4th one, the one that got pushed away, who is now forever stuck in its own state. And that is our electron.
And this, right here, brings us to the most incredible, mind-bending part of this whole story. This model doesn't just explain why electrons and quarks are different. No, it gives the electron a whole new identity, a secret origin story.
This quote just says it all, doesn't it? In a sense, the electron is just a quark that can't change color anymore. I mean, let that sink in for a second. The electron isn't a different species of particle. It's a sibling. It's a quark that, after the Great Breakup, got frozen into a single state, totally unable to change its color and interact with its family like it used to.
And this table shows you exactly how it works mathematically. Look at the top row for the quark. Its little vector there has values for red, blue, and green, but a big fat 0 for yellow. That means it can freely hop between those first three colors. Now look at the electron. It is the perfect opposite. It's got 0 in the red, blue, and green slots, and it is stuck permanently in that fourth yellow state. It really is a lone quark.
It seems like one cosmic family secret might just hold the key to another, leaving us to wonder, what other secrets is the universe still waiting to tell us?